Hello everyone, in this question, a geostationary satellite is orbiting the Earth at a height of 6 hours above the surface of the Earth, where r is the radius of the Earth. The time period of another satellite at a distance of 3.5 hours from the center of the Earth is now. In this question, it is given that it is a geostationary satellite orbiting the Earth at a height of 6 hours, and this is the r equals to radius of the Earth. This is radius of the Earth, and above 6 hours. So this will be, suppose this is the point and above the Earth's surface. So this distance is here, that is 6 hours from the above. So this r1, let r1 is the radius of the Earth. So this is equals to, this is r plus 6 r. So we get here, this is equals to 7 r. Now it is also given that the time period for another satellite at a distance, that is, let it be, this is equals to r2. For another satellite, this is equals to 3.5 r. Now we have to find that the time period. So in this question we have to find the time period. So time period is given by the formula t is equals to, this is equals to 2 pi, and this is root under, this is equals to r cube divided by, this equals to g, and this is r square. We see here this is 2 pi is a constant, and g is also constant, and r is also constant. So we can say that time period t is directly proportional to r. Here the power is cube and this is root, so this becomes r raised to the power 3 by 2. So the time period t is equals to directly proportional to the r raised to the power 3 by 2. So the time period, that is time period t is t1 divided by t2, or we can say that this is t1 by t2 is written as, this is equals to, that is r1 by r2. This is directly proportional, so this is r1 by r2 raised to the power 3 by 2. Now we also know that for a geostationary satellite, time period t1 is equals to 24 hours. So we put this value here and we have to find that is t2. What is the value of t2? And r1 is here, that is 7 r, and r2 is here, that is 3.5 r. Now we have to find the t2. So therefore t2 is written as, this is equals to r2 divided by, this is r1 raised to the power 3 by 2, and this multiplied t1, and we put the value, that is r2 is given here, this is equals to 3.5 r divided by r1 is here, that is 7 r, and whole raised to the power 3 by 2, and time period t1 is given here, this is equals to 24, so this is multiplied with 24. Now this r and r will be cancelled out, this is equals to 7 5 is 0.5, so this is equals to 0.5 raised to the power 3 by 2 multiplied 24, and we solve here, that is, this comes out, this is equals to 8.48 hour. So in this question we have to find the time period for the another, in this question we have to find the time period for another satellite. So time period for another satellite t2 is equals to 8.48 hours. Thank you.
Hello everyone. So today we are going to solve this question. The question says, an artificial satellite is moving in a circular orbit around the Earth with a speed equal to half the magnitude of the escape velocity from the Earth. Then we have to determine the height of the satellite above the Earth's surface. Okay. If the satellite is stopped suddenly in its orbit and allowed to fall freely onto the Earth, find the speed with which it hits the surface of the Earth. So here we have to find the speed with which it hits the surface when it is stopped, and the height of the satellite above the Earth's surface. So now let us try to understand with the help of a diagram here. Let us consider this to be our Earth. Okay. And this to be the orbit of the satellite which is rotating around this Earth. Okay. So now let us consider the radius. The radius of the Earth is here r, and the mass is m. And let us consider this height between the orbit of the satellite and the Earth's surface is h. So let us consider it is moving with the velocity v. Okay, if this is a satellite, so we can say that its mass is m and it is moving with the velocity v. Okay, so now you know that the satellite is moving around this orbit because of the gravitational force. Okay, and also you know that since it is moving in a circular orbit around this center, so we can say that the centripetal force will be acting inside it. So what we can do is we can equate both the gravitational force and the centripetal force here, so that we can find the velocity of this satellite. So now let us start by writing the centripetal force. So what is centripetal force? Centripetal force is basically mv square by r. So here r for the satellite is basically the radius of the earth plus the height. So it will be r plus h. Now what is the gravitational force that is acting on the satellite is? It is g m into small m divided by r plus h whole square. Okay, now so from here we will get v square is equals to gm by r plus h, or v is equals to under root gm by r plus h. Now further, we know that the escape velocity of any object, or here the satellite, is under root 2 g r, where g is equals to gm by r square. Now we know that the escape velocity here, it will be equals to 2 under root 2 gm by r. So now in the question they have given us that v is equals to half of the escape velocity. Okay, now also we know that this is the our escape velocity, and the velocity of that we have calculated of the satellite is this. So now let us equate this. So from here, if we want to write the escape velocity then and the v, we can write it as under root gm r plus h is equals to half under root 2 gm by r. So from here you will get half under root gm by r, capital G, is equals to under root gm by r plus h. Now that is squaring both sides, squaring both sides, we will get here 1 by 4 into 2 gm. Okay, I just forget to put it here. So 2 gm divided by r is equals to gm by r plus h. So from here you will get h is equals to 6400 kilometer. That is basically equals to r. Okay, so now let us solve the second part. The second part say when the satellite stops suddenly in its orbit and allowed to fall free onto the earth, then what is the speed with which it hit the surface? Okay, now let us consider again that if this is the earth and this is the orbit of the satellite, so what we can say from here is that if the satellite is at this, let us consider at this point satellite stops. Okay, so at this point the velocity of satellite will become 0. So here when it falls freely to the surface of Earth, then you know that at this point when v equals to 0, then the kinetic energy of the satellite will also become 0. Now when it is falling down, so its potential energy is increasing. Okay, so now here we can say that the energy is being conserved here. So from energy conservation we can say energy conservation, we can say that the let's consider this to be a point A and this to be point B. So we can say the potential energy at point A minus potential energy at point B is equals to the kinetic energy. Okay, so at point A the potential energy will be equals to minus G m by 2r, because this is also r and this is also r, because this is h and here we have found that h is equals to r. So it will be 2r minus again minus G m by r. From point B it is r. Okay, so that is equals to the kinetic energy, which is half mv square. So if you calculate the velocity value here, it will be under root gm by r. So it will give you under root g r. So from here you will get r. You know that r is equals to 1600 kilometer and g is equals to 10 meter per second square. So by putting the values, you will get v equals to 7.92 kilometer per second. So this is our answer. Okay. So this is the velocity at which the satellite stop and it will fall freely. Okay. So now I hope you understood it. Thank you.
यहाँ पे हमको 2 सैटेलाइट S1 एंड S2 गिवन है एंड वो क्या कर रहा है, एक प्लेनेट को एक राउंड प्लेनेट है उसको क्या कर रहा है कि वो सर्कुलर ऑर्बिटल इन द सेम सेंस से यहाँ पे V1 एंड V2 से मूव कर रहा है एंड बोला है कि द टाइम पीरियड ऑफ द रिवोल्यूशन जो है S1 के लिए 1 आवर है एंड S2 के लिए 8 आवर है एंड रेडियस ऑफ द ऑर्बिटल S1 इज, जो S1 का रेडियस है यहाँ जो R1 है वो हमको दिया हुआ है 10 के पावर 4 किलोमीटर। एंड फिर क्या बोला है कि व्हेन S2 इज क्लोज टू S1, जब S2 S1 के क्लोज आ जाएगा तो उस केस में जो स्पीड होगा S2 का रिलेटिव टू S1 कितना होगा, एंड एंगुलर स्पीड ऑफ द S2 एक्चुअली ऑब्जर्व बाय द एस्ट्रोनॉट इज S1। तो क्या होगा, तो सिंपल सबसे पहले हम यहाँ से रेडियस R2 तो मालूम नहीं है तो R2 को फाइंड कर लेते हैं। टाइम पीरियड हमको मालूम दिया हुआ है तो हमको पता है कि इन दिस से थर्ड लॉ ऑफ द केपलर्स लॉ से जो टी स्क्वायर होता है वो डायरेक्टली प्रोपोर्शनल टू क्या होता है, रेडियस का क्यू होता है। तो यहाँ से हम T1 का स्क्वायर डिवाइडेड बाई T2 का स्क्वायर देखें वो कितना हो जाएगा, R1 का क्यू डिवाइडेड बाई R2 का क्यू। तो डेट मीन्स हमको T1 दिया हुआ है 1, तो 1 का स्क्वायर डिवाइडेड बाई 8 का स्क्वायर इक्वल टू कितना लिख सकते हैं, हमको 10 के पावर 4 किलोमीटर दिया हुआ है तो इसका हम कर देंगे क्यू डिवाइडेड बाई R2 का क्यू। तो यहाँ से हम देखें तो 1/8 का स्क्वायर इक्वल टू कितना हो जाएगा, 10 के पावर 4 डिवाइडेड बाई R2 का क्यू। तो यहाँ से 10 के पावर 4 डिवाइडेड बाई R2 अगर देखें वो कितना हो जाएगा 1/2। तो सिमिलरली यहाँ से R2 देखें तो R2 इक्वल टू कितना हो जाएगा, सॉरी 1/2 का स्क्वायर हो जाएगा, क्योंकि अगर हम 2 के पावर 3 करेंगे एंड इसका पावर 1/3 यहाँ पे करना पड़ेगा तो 1/3 3 कैंसिल हो जाता तो कितना बचता, 1/2 के पावर 2 इक्वल टू यहाँ से कितना हो जाएगा 4 हो जाएगा, 4 इंटू 10 के पावर 4 किलोमीटर। तो हमने यहाँ से R2 को फाइंड कर लिया। तो R2 मिल गया तो हमको पता है कि जो T होता है T इक्वल टू कितना होता है 2πr डिवाइडेड बाई v होता है। डेट मीन्स यहाँ से v देखें, वेलोसिटी देखें तो क्या लिख सकते हैं 2πr डिवाइडेड बाई t। तो ए नंबर हमको क्या बोला है कि द स्पीड ऑफ S2 रिलेटिव टू S1 अगर देखें डैट मीन्स v2 माइनस v1 देखें का मैग्नीट्यूड कितना लिख सकते हैं? हम यहाँ से देखें तो 2 पाई r2 डिवाइडेड बाई t2 एंड माइनस कितना हो जाएगा 2 पाई r1 डिवाइडेड बाई t1। तो यहाँ से 2 पाई कॉमन ले लेंगे तो क्या हो जाएगा r2 डिवाइडेड बाई t2 एंड माइनस r1 डिवाइडेड बाई t1। तो इसको सॉल्व करेंगे तो कितना हो जाएगा 2 into, हम देख रहे हैं कि r2 हमको दिया हुआ है एंड r1 भी दिया हुआ है एंड t1 t2 भी दिया हुआ है, तो सिंपल वैल्यू को पुट कर देते हैं यहाँ पे। तो 2 इंटू पाई का मान पाई के फॉर्म में ही लिख देते हैं। तो 2 पाई इंटू r2 हमको कितना दिया हुआ है हमने जो फाइंड किया अभी 4 इंटू 10 के पावर 4 कितना है 4 इंटू 10 के पावर 4 एंड t2 हमको दिया हुआ है कितना 8 एंड माइनस 10 के पावर 4। इसको सॉल्व करेंगे तो यहाँ से कितना हो जाएगा पाई इंटू 10 के पावर कितना हो जाएगा यहाँ से 4 किलोमीटर पर आवर। तो यहाँ से हमने जो v2 माइनस v1 फाइंड करने को बोला था वो हमने फाइंड कर लिया एंड सेकेंड नंबर केस पे चलते हैं। तो अगर एंगुलर स्पीड देखें, अगर एंगुलर स्पीड ऑफ h2 पूछा है, h2 रिलेटिव टू s1 पूछा है, h2 रिलेटिव है रिलेटिव टू s1 कितना लिख सकते हैं? यहाँ से देखें तो क्या हो जाएगा v2 माइनस v1 डिवाइडेड बाई r2 माइनस v1 r2 माइनस r1। तो v2 कितना हो जाएगा? यहाँ पे हम देख रहे हैं कि v2 माइनस v1 हमने फाइंड किया है कितना पाई इंटू 10 के पावर 4 डिवाइडेड बाई r2 माइनस r1। अगर देखें तो कितना हो जाएगा 3 इंटू 10 के पावर 4। इसको सॉल्व करेंगे तो यहाँ से कितना आ जाएगा पाई बाई 3 रेडियन पर सेकेंड। तो ये हमारा क्या हुआ आंसर हुआ। तो हमको सिंपल एंगुलर स्पीड ऑफ द h2 रिलेटिव टू s1 फाइंड करना था, वो कितना हो जाएगा पाई बाई 3 रेडियन पर सेकेंड। एंड फर्स्ट में हमको क्या फाइंड करना था कि जो भी रिलेटिव स्पीड होगा h2 एज कम्पेयर टू s1 डैट मीन्स स्पीड ऑफ h2 रिलेटिव टू s1 जो हमने यहाँ पे फाइंड किया वो कितना आया था पाई इंटू 10 के पावर 4 किलोमीटर पर आवर। तो ये हमारा आंसर हुआ।